Hello friends, hope you are having a fantastic day today. Scalability is one of the most important key concepts for any system design, and today we are going to go much deeper into everything related to scalability and scalable systems. We are going to see what are the type of scalability options available to us, what are some of the challenges associated with scalability, and maybe see one example of a real life scalable system. So I hope you find this video useful. So first concept we are going to talk about is going to be scalability. This is a really important topic for any system design that you are planning to design, that you have to understand that whether system is scalable enough or not. Now, what does scalability mean? If we see the definition of scalability, it simply defines that it is the ability for any particular system to handle the increased load efficiently without having any issues and without having any impact on the outside user. So say for an example, if this is your Instagram system, right? Now we all know Instagram is one of the most popular services out there. Now initially when Instagram started, it only started with few hundred or few thousand users. Let's say that there were 10,000 users who are using Instagram and they were able to use it efficiently. But sooner or later, Instagram became more and more popular, and now currently billion people or more than that actually use Instagram. The thing is, even for these billion peoples, Instagram is still behaving the way it should, which means we can define that Instagram is handling the scalability principle, or the system that Instagram has is actually scalable with the increase in the user growth. Now, question is, how do we actually achieve scalability? We all know that if we have any particular server or any particular computer where we are running our system, basically what would happen is that, let's say your application or the number of users who are calling your server is keeps on increasing. So what would be the first thing that would come to your mind? First thing that would come to your mind is that, let's say this computer is currently 16 gig in memory, and it is, let's say, 1 terabyte in SSD hard drive, something like that. These are the configurations, and you see that there is a rise in the number of users calling it. The first thing that would come to your mind is that make it a bigger, better, stronger computer. So what you would end up with is you are actually going to have, let's say, 32 gigabit RAM, then you are going to have 2 terabyte memory, then you are going to have graphics card, something, and then your system would work fine. This is what we typically all did when we wanted to play higher versions of Call of Duty. That we would just buy better gaming PC, and our PC would be able to accommodate the new version of more powerful games. So this, what you are currently doing is that you are increasing the scale of the existing computer, which means vertically we are going higher in the capability of our system. That is defined as vertical scaling. Now this is a really important concept, because many times all you need to do is just increase that available number of computers you have to grow them in a much higher capacity to handle higher amount of load, higher amount of user, or higher amount of system traffic. So vertical scalability works perfectly well. Let's say that you kept going higher and higher of, let's say, RAM to be 128 gigabytes, and then you have 10 terabytes of memory, and you have like the best graphics card in the world. Still the number of users keep on increasing. What would you do then? So the next approach would be to go horizontally, and that to have a number of the systems that are similar or different to each other talk with each other. So what would happen is that the number of users who are calling, let's say the number of users they are calling through a system that looks like this, that was originally this version over here, but in the back end this system actually calls all of these multiple computers to do all the computation. Let's say you take care of all the networking bandwidth, you ensure that the latency is quite low and all the traffic gets routed and all the requests are being completed successfully, and then you return back sufficient answer to the growing demand of the number of users. In that case, you are increasing the number of computers you have. So this increase would actually define as horizontal scaling. This is also very important in the system design, that you need to increase horizontally. Now the question is when to use vertically and when to use horizontally. In my opinion, it's not going to be either one of them. In most of the cases, with the increased load, you also need to increase the capability of the existing computer. So you are going to go higher in the vertical, and with the increased load, you might have to add some more computers to your existing system and have them talk to each other in the most efficient manner. So that way, all the calls get routed properly and your users are able to use your system flawlessly. So this is a key concept of horizontal and vertical scaling, what it means.
Now don't think that scalability is easy to achieve, because if it would be, then we would have like 10,000 Netflix or 10,000 Facebook like companies. These things are really challenging to manage that. And why it is challenging? Because let's take for an example this previous scenario, where we actually currently have 6 different computers speaking with each other flawlessly to complete some requests that are coming in from the users. And the number of users, they keep on increasing, and there are like millions or billions of requests happening every single day or every single hour. So the first thing that would first challenge would be to have the same response being sent by all of these computers. What it means is that many times in the system you are also going to be dealing with data. So what would happen is that for your existing system you will also have some database where you are storing some value of the customer, and let's say all of these systems, they are connected with this database as well, and whenever you need, you are able to get some appropriate answer. But one potential challenge would come in places that, let's say currently user 1 has the name as Parth. So I'm going to mention the name as Parth. Now this user 1 decides that I want to change my name from Parth to, let's say, Hinal. That is my wife's name. Okay, so now I need to go to change the name to Hinal. I send out a request to this system. This system randomly calls any one of the computers. So let's say it calls this computer, and now this computer has updated the name as Parth. But the thing is, all of these other computers, they are still connected to the older instance of this database. And immediately before these computers can get notified, let's say I want to change the name again, something else to, let's say, Tana. Okay, so if I change the name to Tana, again I make the call to the system that, hey, what is the name? So let's say this time system came over here, and this system wants to fetch that what is the currently name saved in the user database. So in the user database, this system does not know that this computer has changed the name to Parth, and after Parth, let's say this computer also changed it to Tana. So it is possible that this system, they might give us back the answer of, let's say, that it says that this is the name is Parth or the name is Hinal. Meanwhile, the actual name is actually Tana. So this is a problem occurs when you try to manage the states across all the instances. So number one problem with the scalability is that state management, that you need to make sure that all the states are being same, and there are no issues with that. I'm sorry for butchering the spelling, but you got the idea. Now second issue that comes in is the load distribution. Why load distribution is the issue? Because let's say that you have 15 computers running parallelly with each other, and your service is sitting somewhere on top. Now in your system currently, let's say you have put the load distribution, but for the load distribution, the hash you use is not very good. Like the plan you use to connect these calls are not very good. What would happen amongst these 6 individuals? Let's say that only 5 gets called every single time, and because the algorithm is set in such a manner for this load distribution that this server never gets called, what would happen is that all of these computers, they would keep on running out of memory, and this is going to stay idle, and this is going to be bad for your overall efficiency of your system. So load distribution is another issue with scalability. Third issue is the data sharding, and data sharding is actually quite complicated, and I wanted to talk about this later. But let's just say that same way we have great multiple computers speaking with each other, same goes for database, that we are not going to have one big database that is connected all across. There would be multiple versions of database, and there would be different data being stored, or the partitions of data being stored in each of the database. So suppose it could be possible that we put down the condition that if the number of users alphabet starts with, like, let's say A to P, then store it in this user database, then P to, let's say, S, store it over here, then S to, let's say, V, store it over here, something like this is our algorithm to dictate that what the database should store. Now let's say that currently a person named Beta decided to make changes, so that change is going to reflect over here. But again, after some time, this Beta actually changed its name completely to Sally. Now the name is Sally. Sally makes change, that change should be reflected over here, but we still have the older version of Beta that has some change being stored over here. So now that this becomes the inconsistency amongst database. So again, it becomes tricky to manage the number of database with the increased scalability. And also even for this database, we also need to have scalability implemented in them as well. Why? Because we don't know that when the number of load is going to increase, and we might have to increase the number of instances of database as well. So there are a lot of issues. If we want to take best example of scalable system, we don't need to go much far. Let's consider the example of Amazon, because in Amazon typically it deals with large number of data. There is no issues with that. But let's say when we have Black Friday coming in, or we have Boxing Day coming in, the number of users that are going to be using Amazon is going to be double or triple in the same day, and that puts a huge amount of load on the Amazon servers. Now what happens if Amazon server starts crashing during these days? Of course, these users, they are going to have bad experience, and Amazon is going to lose ton of money. So that's why Amazon has to ensure that their systems are scalable, and they are able to handle the increased load efficiently. So this is quite important key concept for distributed system.